Two bright beams of sunlight are traveling across your forehead, cheeks, eyes. Ooh! You scrunch up your face and sneeze loudly. It would be nothing unusual if the sun's rays weren't coming from two different stars. Yep, you're still on Earth, but this Earth has two suns. What would your life look like in such a world? It'd depend on the stars' mass and their positions relative to Earth and each other. If the stars were small, their gravity wouldn't be enough to keep our planet in its orbit. It'd eventually drift away into space. But if one of the stars was larger than the other, it would have a much stronger gravitational pull, and sooner or later, Earth would end up too close to it. It'd become too hot to live on the planet. You know, boiling oceans, evaporating rivers and glaciers, and scorching hot air. Lovely. In the end, our once blue world would crash into the star and, disappear. The only chance for Earth to have a stable orbit would be to move around only one of the two suns. But it wouldn't be that great for all kinds of life forms on the planet. Every once in a while, the two stars would face both sides of Earth. It would mean there would be no nights. Our planet would get twice as much heat as usual. It'd also be bombarded with double doses of radiation. And of course, solar winds would become twice stronger. During such periods, you'd have to hide indoors and probably order drone delivery. Because you set your foot outside, the two suns would get you toasted in no time, what with all that heat and solar radiation. Uh-oh, it doesn't sound optimistic. Maybe it would be better if our planet was moving around both stars. Perhaps. Its orbit would be rather unstable in this case. And still, it would be better than experiencing crazy heat waves every now and then. But in this situation, the stars would have to be close to each other, and Earth would most likely travel too far away to get enough heat to keep its water liquid. If our planet had been developing in such conditions from the very beginning, now it would be just a frozen rock with no life on it. How about the most optimistic scenario? Our planet would get itself two similar-sized stars, and each of them would be more than half as powerful and bright as our current sun. By the way, it sounds rather realistic. Such equal-mass double stars do exist. Their common gravitational pull would be just enough for Earth to not fly out into space, and the amount of energy our planet would get would be more or less the same as it receives now. But the combined mass of the stars would be about 1.5 times the mass of our current sun. It would mean their gravity would also be stronger, and 1 year on the planet would be shorter. It'd last not 365, but around 280 days. But Earth would only feel comfortable if it was at least 4 times farther from its stars than they were from each other. Then our planet would happily move around their common center of mass. In other words, the suns would have to be less than 10 million miles apart. Then the rest of the planets in the solar system, including Mercury, would have stable orbits. If you lived on the Earth that was moving around two stars, you'd be able to watch awesome solar eclipses. But it would not be the moon blocking the sun, but one of the stars preventing you from seeing the other. Instead of several minutes, eclipses would last for hours on end. They would also occur much more often, maybe once in a week or so. If the stars were a bit larger in size, there would be 2 types of eclipses. Every now and then, a smaller star would block the larger one, but only partially. But when the bigger star blocked the smaller, it would result in a total solar eclipse, complete darkness. 2 suns would mean days would become brighter. Nights, sunrises, sunsets, these would change too. The star would set and rise at different times. So, arriving too late to watch the sunset? It wouldn't be a problem. You'd still be in time for the second one. With 2 suns, the seasons on Earth might also start to change more rapidly. They would be harsher than now. Most life forms on the planet would be struggling to keep up with intense and fast climate changes. But returning to the combined gravity that would be stronger than what we have now. Because of this, everything on the planet's surface would look different. Trees would be thick and short, plants stiff and tough. Animals would be way bigger and sturdier. Their legs would be more massive to support their weight. It would increase due to the stronger gravity. People would most likely be bulky and short. Their bones would be thicker, either to withstand higher gravity or because of constant breaking and healing. Humans would also have stronger muscles, lungs, and hearts. Well, at least the gravity wouldn't double at once. If it happened, our planet's core would probably collapse on itself right away. Then it would release so much heat it would burn everything on the surface, like us. Even if the gravity was increasing gradually, adapting to this new world would still be a challenge. Buildings and bridges would collapse under their new weight. Planes wouldn't be able to fly. In any case, discussing what Earth would look like with two suns is nothing but a guessing game at the moment. But scientists know for sure that such planets do exist. Kepler 16b was discovered by the Kepler Space Telescope. The planet, the only one astronomers know about so far, orbits two stars. It has beautiful double sunsets and is around 200 light-years away from Earth. But this planet isn't a welcoming one. It's the size of Saturn and extremely cold. Kepler 16b is mostly made of gas. It might have a rocky core, but astronomers aren't so sure about that. The planet is also out of its star's habitable zone. That's the area where there might be liquid water. Plus, the stars are colder than our Sun and much smaller. One of them is less than 70% of our Sun's mass, and the other just 20%. That's why scientists are almost sure no life could survive in such a place. It's highly unlikely Earth could be developing in the same way, even if it was orbiting two stars. After all, our planet isn't a gas giant like Kepler 16b. But if this had somehow happened, Earth's fate would be very different now. The temperatures on the planet's surface would be lower than minus 100 degrees Fahrenheit. All water would be frozen, and the chances are Earth would never have turned into the blooming green paradise we live in. At the same time, our Sun might have had a companion long ago. It could be Nemesis, a theoretical dwarf star. If it had been a white dwarf, just a teaspoon of its matter would have weighed more than 5 tons. It's almost as heavy as an elephant. White dwarfs are extremely dense. They can be the size of our planet, but as massive as our Sun. Such a dwarf star could be responsible for several mass extinctions on Earth. Scientists think it could somehow affect objects in the outer solar system. It's the region which is home to giant planets, Jupiter, Saturn, Uranus, and Neptune, and their moons. Anyway, Nemesis could push different space bodies off their course. Then it probably hurtled them toward Earth, where they collided with our planet and caused terrible disasters. It's just a theory, though. Many scientists don't support it, and astronomers haven't found any evidence yet. But a 2017 study suggested such a star could exist in the ancient past. Even better, the researchers claimed each star, like our Sun, was once born with a companion. But even if Nemesis had existed all those billions of years ago, it would have broken free of the Sun's gravity quite early in its history, and then it would have wandered off into the Milky Way.
It was September 2nd, 1859. People all over Europe and North America woke up at night, confused and still tired. They were sure it was already morning. It was so bright outside. But when they looked out of their windows, they discovered it wasn't sunlight. The skies were lit by countless intense auroras, red, green, and purple. They were so brilliant, one could read a book as easily as in the afternoon. Auroras appeared even in the regions where they had never been witnessed before, like Cuba, the Bahamas, Jamaica, and Hawaii. Cool visual effects weren't the only thing that both mesmerized and horrified people. The most high-tech stuff at that time, telegraph wires, shorted out throughout Europe and the US. Sparks were flying from equipment, and many human operators got electric shocks. Papers in telegraph offices burst into flames. All the machines were immediately disconnected from their batteries, and still, they mysteriously kept sending broken messages. Fires, ignited by short circuits, spread over large areas. Colorful lights kept dancing overhead. All this caused panic and total confusion. Earth's inhabitants had never seen or experienced anything like that before. At that time, very few people knew that the Sun was to blame for the chaos. One of them was English astronomer Richard Carrington. At about 11 a.m. on September 1st, the man was standing by a telescope in his private observatory. He was watching sunspots on the surface of the sun. Suddenly, 2 patches of intense white light broke out. They looked as bright as direct sunlight. At that moment, the astronomer didn't know what a terrible commotion these flares would cause. Later, it became clear that the sun had produced an epic geomagnetic storm and unleashed it at our planet's protective layer. Wave after wave of charged particles slammed into Earth's atmosphere. The planet's magnetic field wasn't powerful enough to stop them. It gave way, and the storm hit Earth, causing havoc. The phenomenon got the name of the Carrington event. So far, it's been the worst solar storm ever recorded. Good thing it happened when people didn't have advanced technologies and weren't that vulnerable to the sun's geomagnetic fury. The 1859 solar storm was 3 times more powerful than the one that happened on March 13, 1989. 3 days before it began, astronomers watched a massive eruption on the sun's surface. Within a couple of minutes, a billion-ton cloud of gas was hurled away from the star. It rushed straight toward our planet at a speed of millions of miles per hour. On Monday the 12th, the huge mass of solar plasma reached Earth's magnetic field. This storm was so fierce, it lit spectacular auroras and created underground electric currents beneath North America. These currents must have found some weaknesses in the power grid of Quebec, Canada. In less than 3 minutes, the entire city lost power. Millions of people found themselves in pitch-black streets, dark buildings, and stuck elevators. They woke up in freezing cold homes, unable to cook breakfast. The following 12-hour blackout closed businesses, airports, and schools. The Montreal Metro was also shut. In the U.S., hundreds of power grids started to have problems minutes after the storm hit Earth's surface. Luckily, none of these issues led to a blackout. The storm was severe enough to disrupt satellite communication systems and radio signals. Some space satellites tumbled out of control for a few hours. Lots of them had mysterious problems that went away as soon as the storm began to subside. No newspaper mentioned it, but in 2012, Earth had a close shave after narrowly missing an extreme solar storm, the most intense in the past 150 years. On July 23rd, astronomers at Space Weather Prediction Center in Colorado spotted 2 clouds of energetic particles. They erupted from the sun's surface and barreled into space. Just 19 hours later, these clouds zoomed past the spot our planet had just left. If the solar eruption had happened several days earlier, Earth would have ended up in the line of fire. So, what if a solar storm as powerful as the iconic Carrington event happened nowadays? How much more harm would it cause? Would our life get back on track after such a disaster? Before you learn the answers to these questions, let's figure out what a solar storm is. The sun is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can speed up to more than 600 miles per second. The most powerful volcanic eruptions pale in comparison with solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. When people think about danger coming from space, Most of them imagine an approaching asteroid, like the one that wiped out the dinosaurs. But apparently, we should be much more worried about our good old sun. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, several days later, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have a mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the sun would damage giant transformers. Those take ages to replace, especially if hundreds or even thousands get wrecked. In some places, a failure of one power grid would make others collapse as well, creating a domino-like reaction. Picture living without electricity for a day, a month, a year. No light, no computers, no phones, water supply systems out of order, no food in supermarkets. Plus, without electricity, it would be next to impossible to reboot the already failed power grids. A powerful solar storm would cost people $1 trillion to $2 trillion, and that's just during the first year after it happens. It would take the world another 4 to 10 years to recover. The damage to all kinds of satellites alone would reach $70 billion. Under majestic auroras, people would have to get used to a new, dramatically different lifestyle. No doubt, we'd have some kind of warning. Modern equipment all over the world and in space doesn't stop watching the sun even for a second. Once a bad solar storm happens, people would have some time to prepare, between several hours and a couple of days. And if transformers are taken offline in time, the consequences won't be so dramatic. Now, the following news might sound scary. There are also super flares. In comparison to them, our sun's bursts of radiation are small potatoes. Super flares mostly occur in young and active stars. In 2016, astronomers saw such a phenomenon. A star 1,500 light-years away from Earth produced a flare that was 10 billion times more powerful than any of those that burst from our sun. It doesn't mean we're safe here on Earth. Even our middle-aged sun knows how to produce super flares, but while young stars can have them once a week or even more often, for the sun, it's once in a few thousand years. And still, if people don't figure out how to protect the planet, just one super flare can shred our ozone layer and wipe out life on Earth. Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So, they turned to the stars to find out what the reason might be. And then, they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light-years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's gonna be a fun car trip. 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's gonna be as chaotic as can be. In stellar mechanics, it's called the three-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how 3 stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who'll have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe. So, they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. but it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Shoals bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between 2 stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.